Good morning, everybody. This is a live severe weather briefing discussing the next 3 days of high plains severe weather threat. It looks like eastern Colorado could be quite active, including some high base storms today across southeastern Wyoming into northeastern Colorado. Then it looks like each day that severe weather threat increases across eastern Colorado, maybe even moving toward the southern plains on the Sunday-Monday time period, but it certainly does look like the warm sector is going to be quite capped. That's basically a warm layer of air just above the ground that prevents those parcels, surface-based parcels, from breaking through and taking advantage of those deeper lapse rates. My webcam is still not functional. That's why I've got a still photo up on the upper right, but I am wearing one of my favorite shirts today, so I figured I'd put that still photo up there, make this briefing seem a little bit more personal, but I am going to get that fixed where I can actually hook up my USB webcam through VHS-C. But I also wanted to show you the Tescott intercept. That was from Tescott, Kansas. That was exactly 2 years ago, May 1st, 2018. There you could see the tornado as it was intensifying just after the intercept of Dominator 3. And we intercepted this tornado pretty early in its life cycle. This video is not in chronological order. This is looking off to the northeast as the tornado is really intensifying, and this is after we intercepted it. We actually intercepted this tornado just after it formed. I kind of wish we waited a little bit until the tornado was more mature. Here you can see it expanding into the wedge phase, and you've got a wall cloud above it. That's the condensation that is above it, rotating around and developing into a collar cloud here. That's that area of condensation that's wrapping around the tornado vortex. But then as the vortex gradually matured, that condensation cleared out. You could see straight up that clear slot. You could see that white part on the top of the screen. That's the clear air or clear slot that's cutting into the larger mesocyclone above, and then that concentrates the tornado vortex there within the mesocyclone. It's a smaller scale vortex that can be much more intense, and basically you have a vacuum cleaner that's tilted above it. That's the mesocyclone, and then once the mesocyclone reaches a certain strength at the low levels, the air is forced to go across isobars. We call that cross isobaric flow and toward that low pressure. That's because the low level mesocyclone will intensify so rapidly that it can't maintain forced balance at the low levels near the ground. As that wind speed is slowed down by surface friction, that causes it to cut in toward that low pressure, and that's where you see the clear slot. There is a bit of an argument as to what comes first, the chicken or the egg. Does the clear slot come and then enhance the cyclonic vorticity on its north side beneath the mesocyclone so that that eddy can be stretched into the vertical and couple with the mesocyclone? Or does the tornado form and then the clear slot wraps around the south side of it? At least based on my experience, I always see the clear slot and that cross isobaric flow develop first, and then I see the tornado vortex form. Sometimes, though, you'll see the low-level mesocyclone above with that clear slot enhancing the upward motion or strengthening that vacuum cleaner, and then when a gustnado happens to propagate beneath that vacuum cleaner, it then becomes a candidate to develop into the tornado. That's when I believe that we have the ground-up type of development with tornadoes, but I also believe that they develop from the top down through a process called dynamic piping. That's when you get a strong low-level mesocyclone, you get that cross-isobaric flow, the enhancement of the cyclonic vorticity, and it's able to drill down from the top down through a shallow stable layer. It seems like those tornado vortices that are more tilted, they seem to, and with a presence of greater 0 to 3 kilometer instability or low-level lapse rates, those are the ones that don't seem to develop from the bottom up a bit more. When you have those strong low-level lapse rates, when you have low-level stable air, then it requires the tornado to dynamically pipe from the top up down to the bottom. That happens a lot during evening, late evening, and the overnight hours, and you get the development of intense convective inhibition. This tornado, you can see, is pretty vertically oriented. One thing we learned from launching the rockets into the tornado is that at least that tornado to the southwest of Linwood was a vertically oriented vortex up to about 10 or 11,000 feet, and then it attained rapid tilt descent all the way to the top. So I think that some tornadoes are tilted from the ground up, some tornadoes are more vertically oriented, but really the only part that we can see is the part below the condensation or even below the wall cloud, and that vortex likely goes up 5, 10, 15,000 feet before developing that tilted descent. But this is looking northeast after we intercepted it turned into a cone stovepipe. Then we tried to catch back up and do these intercepts from south to north. But then it developed into a large wedge, as you can see here, 2 years ago, exactly on May 1st. And now I want to go over some of these chiclets, as we call them. This is the climate forecasting system. It's run jointly by NCEP and the University of Columbia, IRI. And this was developed in 2011. And this is a way to analyze seasonally regional and global anomalies, also to do seasonal and longer forecasts. But this is a medium to long range forecast model. And each of these boxes, or chiclets, represents a continental United States area average of 48 grid points of the supercell parameter. And let's see if I can slide this to the right just a little so you can see the, there it is. And a supercell parameter, obviously the red is a much higher area average of the 48 grid points, and it is across the entire continental U.S. So you can get a very small region that has a high supercell parameter, and then the rest of the United States has a very low supercell parameter, and that may not register as much. But you can see that white line that goes across the diagram. This is right here, whereas everything to the left of that line is an old forecast, and everything to the right of that line is a forecast out in time. And this is a good tool to use to see if the severe weather season in the next 2 to 4 weeks is going to be active or not active. And it looks like you've got a lot of red here toward the second half of May. These are the dates along the bottom. So you can see here the date is May 15. So it looks like just after May 15, you have a influx of a widespread high supercell parameter, likely over the southern plains or Tornado Alley, maybe some Dixie Alley, but we're starting to get to that point in the season where we're transitioning from Dixie Alley to more of a Great Plains traditional Tornado Alley type time period. You can see that, and each of these are a different forecast run at 12Z. So this one was from April 19. This one you could see was from late March, so it doesn't go out as far. But this is a more recent forecast up here in late April along this top line. And these more recent forecasts are fairly consistent. It's also a great way to look at forecast run-to-run model consistency. So this is a previous run, this row is the run before that. This row is a 12Z run before that, 12Z being 7 a.m. of the climate forecast system. And so what this is showing is that there is a lot of run-to-run consistency. When you look at the columns and see if there's a lot of reds in each column, that shows that there's consistency in this forecast. This is near late May into early June already out there. So this is showing that the second half of May is just going to go bonkers into early June. And usually during the storm season will breathe a little bit and ebb and flow. Here you can see as these systems were coming in at about a 1 week periodicity early on in the season. Remember how they were almost every single week? Then you had a subtle system slide in between there. But every week you had a pretty big system. The Easter system is represented by this group of chiclets, which picked up on that forecast at the last second. But you can see that there wasn't a lot of run-to-run consistency leading up to the Easter outbreak. And then it kind of came together at the last second, especially right up here. So it looks like the CFS forecasted it right around April 1st, even 10 to 12 days out, and then backed off that forecast quite a bit, and then bam, really ramped up at the last second for that Dixie Alley event. But really, Dixie Alley was the only area that showed that strong supercell parameter, and that's why these may not be quite as darker colored, darker red later on. But you can really see these big time chiclets here, darker red. That shows that there's more widespread, regionally robust supercell parameters there. And during the next 10 days, though, you can see some of these models out here were showing a pretty active May. This was when everybody was getting all fired up that the first 10 days of May were going to be crazy. But now it's kind of backed off of it a little bit. But you can still see the next 3 days here of a high plains insanity, eastern Colorado into the southern plains is being depicted there. But let's break down some of the shorter range models now, so that over the next 3 days, And here is the models. This is the NAM model. We'll break down first. The trusty NAM. I'm familiar with its biases, and I just like familiar things, like the Dominator 4 or an old pair of jeans. But here you can see a big East Coast trough, and that has definitely cleared out the Gulf of Mexico. The surface map I just had the surface map up. Let's go back to the chicklets. I want to show the surface map. And today there is a chance of severe weather across southeastern Wyoming, the far northeastern Colorado. But look at these dew points. They're only around 40 out here. You've got some evapotranspiration a bit up against the Colorado foothills and the high plains. Dew points into the low 40s there. You can already start to see the hint of a Denver cyclone forming. You've got northerlies in a post-frontal environment. Eventually these are going to swing back around to an east to west direction, and that's going to create some upslope. High base storms should develop off of Elk Mountain here, off the Laramie Range, and those will move off to the east and the southeast across southeastern Wyoming into far northeastern Colorado. But they're going to be incredibly high base. Dew point spreads are 30 to 40 degrees. Here is 78 over 35. That's a 43 degree dew point spread. But the dew points in the post-frontal environment here are going to get better and better as we go day by day. You can see even some upper 40s dew points up here into the western Dakotas, western Nebraska. So once these winds shift over to an east-west, it should pump some of these greater dew points back to the west. But look at over the plains. Texas Panhandle, you've got dew points in the upper 30s to around 40. Oklahoma, you're probably going to rise into triple digits here potentially in the next few days as dew points are dropping. More of a summer-like pattern. Could be a building in of a big western U.S. ridge for the first 10 days of May. And then at least those chicklets, the CFS, is definitely showing a more active second half of May. So here is the NAM model, and you can see this band here of southwest to northeast oriented flow. Just a little bit stronger flow there that's coming in. That's the beginnings of this 3 days in a row of severe weather starting today across southeastern Wyoming into northeastern Colorado. Quite a potent jet streak. If this jet streak were coming through in June or July, we'd probably be talking about a pretty decent tornado setup across southeastern Wyoming. We'll be all over those as we get closer to the middle of the summer and chasing high plains insanity. But you can see that the southern gradient of that stronger flow is right near the Colorado-Wyoming border. Let's see what the NAM has for dew points up in this environment. Then we'll look at some of the other models. So the NAM is definitely showing those dew points to be in the 40s, but it is showing some east to west advection of those deeper dew points that are now over the Nebraska Panhandle and western South Dakota into the high plains. Dew points in the low to mid 40s are plenty to get even severe storms up here in eastern Wyoming. I saw a tornado a couple years ago, the first tornado of the state that year, and the dew point was about 43. It was an early season event, late April there, near Agate, Colorado, just a dust swirl underneath a big rotating low-level mesocyclone. But up here in Wyoming, I could see there being, especially to the north of Cheyenne, maybe up near the Lusk area to the west of there, I could see there being a couple of severe thunderstorm warnings, some high base storms, a lot of evaporational cooling. Even with this sounding, which we cherry-picked to have some deeper moisture, you're still talking about a 20-degree dew point spread, but you can get tornadoes in these environments out here in eastern Colorado. Here you can see the northeasterlies. This is kind of the day before the day in terms of a good upslope event. These winds are going to be more east to west tomorrow, as we'll look at in Colorado. Let's see what it does with the moisture here over the next few days. So this is tomorrow, Saturday afternoon. Quite a bit of a marked increase in moisture here across eastern Colorado. Even Denver's got a 47 dew point tomorrow afternoon at about 3 p.m. Deeper moisture coming into southeastern Colorado as well. There definitely are some olicity tracks that are being shown in this environment. Let's look at the next day now on Sunday. Sunday also a southeastern Colorado event with dew points in the low 50s. More of a southeastern Colorado, western Oklahoma panhandle type of an event on Sunday. But you can see some deeper moisture starting to lift north in southern Oklahoma. I'm just kind of glossing over the models today just a little bit, but we'll look at all the different runs here. Quite a bit of a Cape blob starting to organize there on Sunday across the southern plains, but likely will be capped across this region, or at least so far southeast of the main wave. Limited vorticity advection, limited convergence along boundaries except for a dry line in the western end of that. But look at this capping inversion across the plains. So even though you've got dew points in the low 70s, you have such a warm layer just above the ground in between 700 and 850 millibars that it's just going to be impossible to get any convection in that environment that far east. However, here in southeastern Colorado, with those dew points in the low 50s on Sunday, I do think you're going to break that cap with the help of the terrain. And this is a decent sounding for Colorado here, although you do have an inverted V sounding, it's called, very dry, low levels. See how the dew point line is far separated from the temperature line here. Usually you get southerlies in this environment, and then there's a west to east oriented boundary where you get more moisture, lower cloud bases. So this is probably just south of that west to east oriented line, but some decent kinematics here for supercells in southeastern Colorado on Sunday. Saturday looks like a decent day, especially in southeastern Colorado, maybe up toward the Front Range too, 750 to 1,000 capes, even all the way up into Denver. Certainly going to be some storms out there. Maybe the Denver cyclone could be in play for some land spouts. Get a land spout beneath there. The Denver cyclone or Denver convergence zone is an area that develops here near Denver that is basically shaped by the terrain. You've got a west to east oriented Palmer Divide. That can act to generate cyclonic curvature and convergence near and just to the north of Denver and near the airport. So when you get convection that develops near the vicinity of that Denver cyclone, you can have some enhanced curvature at the low levels, some enhanced low-level vorticity. A storm moves around this area, can stretch that into the vertical, and you can quickly get land spout type tornadoes. And this is a decent sounding even for transient supercell structures. This is near the Denver area, NAM-derived sounding, storm motions east, a little southeast at about 20 knots, 1 kilometer wind. You've got some easterlies here, some weaker easterlies. You'd like to see some stronger easterlies of about 20 knots, flipping around to the southwest to really elongate that hodograph. But it's early season for the high plains. Let's see down near Raton Pass, though, tomorrow. Raton Pass doesn't look too much better, but we'll just have to wake up and look at the surface map and see what the dew points are. The NAM is definitely hinting at a tongue of moisture, though, coming up through just south of Capulan volcano there. Here you got some dew points in the low 50s. So really tomorrow, you got to decide whether to target the Denver convergence zone up here, where they have some pooling of the moisture, or do you target this tongue of instability coming into southeastern Colorado near the Raton Pass area? Could be some decent supercells turning right, propagating into that moisture. Let's look at 0Z. 0Z, look at that tongue, becomes even more well-defined into southeastern Colorado. So there's going to be supercells that are going to move southeast into this tongue of instability and moisture in Colorado there, most certainly. I'm going to pop over here, take some of your questions. Hi, everybody. Yeah, Ku, I can explain cyclogenesis just a bit, Lee cyclogenesis especially. So with this event, this is on Saturday evening, there are a couple different processes that can lead to pressure falls. You don't have a big low pressure forming to the east of this. That's because you've got some ridging aloft. But then if you go to Sunday, there is going to start to be some Lee cyclogenesis. And the reason why is because you start getting some cyclonic curvature. This is at the mid and upper levels of the atmosphere. This is at 500 millibars. So once you start getting this cyclonic curvature aloft, that's called positive vorticity advection. When that happens, that leads to low-level pressure falls. And it's basically in the inflection point between a trough and a ridge where you get those low-level pressure falls. Let's see if we have a Lee cyclone that's forming in this one yet on Sunday evening. And there it is. There's that Lee cyclone across southeastern Colorado, dropping to about 1,000 millibars. This is a textbook Colorado low. And so when these become vertically stacked, so very early on, the trough is to the west of the surface low and they're a bit displaced, similar to a tornado. When a tornado vortex is tilted, it's strengthening. Then it becomes vertically oriented upon occlusion, then ropes out and dissipates. A similar thing happens on the synoptic scale as well, where you get the surface low intensifying as it's not vertically stacked. So when there's some tilt between the upper level cyclone and the surface cyclone, this cyclone is still intensifying. It's in the inflection point between the upper level trough and the ridge off to its east. That creates rising motion in the mid-levels of the atmosphere. That creates pressure falls at the low levels of the atmosphere, cyclogenesis at the low levels. And here you can really see the upper wave. This is a cyclonic curvature there. This is the trough axis extending south from that trough. It is kind of subtle, but it is strong enough flow to generate Lee cyclogenesis and development of that Colorado low. And then as the low intensifies over the coming days, sometimes they'll bomb out and become vertically stacked. And then that's just before they become vertically stacked is when they reach peak intensity. Then you start to fill in that column a bit, as we call it. You get low-level pressure rises. The upper level system is vertically stacked with the surface cyclone. And when they're tilted like that, they're feeding off of the temperature gradients as well. So then the cold front develops, surges south on the backside of that cyclone. The northerlies, you get cold advection on the backside, frontogenesis here on the backside of that low. To the east of the low, you get warm advection. That contributes to height rises in the mid and upper levels of the atmosphere. That can make the ridge more pronounced. The cold advection on the backside can also help to make the trough more pronounced and steepen that inflection point between the trough and the downstream ridge. And then it continues to intensify until eventually it becomes vertically stacked with the upper system. That means that basically the upper system is co-located with the surface cyclone. In this case, they're still well separated. Here is the upper level system. The cyclone is still down here. This is on the GFS. And there you can see the upper system is still intensifying. Let's see where the surface low is on Tuesday evening. This is on Tuesday evening. That's the upper level system there over the western Great Lakes region. So now you can see that the upper level system over the western Great Lakes and the surface cyclone are nearly co-located or vertically stacked. And now the surface low begins to rise. Those pressures now have risen back up to about 1,000 millibars. The system peaks across the southern plains on a Sunday, Monday type time frame after 2 days of severe weather in eastern Colorado. And now this thing's vertically stacked. It's beginning to fill in, as we call it. The surface low is no longer oriented at the inflection point between the trough and the ridge. The trough is beginning to become, filling in cold air. The cold upper level of vorticity maximum is located directly over that surface low, and then it will begin to fill in and has reached its peak. Kind of shears out, then we'll move off the east coast. Sometimes, though, these will reinvigorate, and you can see the development of a coastal storm a little bit there off the coast. This has become an open wave again. And so even though it did become vertically stacked over the western Great Lakes, on approach to the temperature gradient off the east coast, you get another cyclone that's forming, almost like a cyclic supercell, where you get one tornado that'll rope out, occlude when it becomes vertically stacked, and then you look off to the east, and you see another tornado developing. There's a lot of similarities in the different spatial scales between the storm scale, mesoscale, and the synoptic scale. It's just when you get on these larger scales, then the Earth's rotation becomes more relevant. Coriolis force becomes more relevant. So you've got to factor in the Earth's rotation a bit more. But when you're on the smaller scales, the storm scale, these mesocyclones, even hurricanes, they factor in the Earth's rotation a lot less. And then we get the development of this ridge. Here's a bit of a ridge runner here that could lead to some more high plain severe weather around May 7th. This is the GFS, of course, which people like to people don't like to view a little bit, but you can see this development of a mega trough, negative geopotential height anomaly there over the northern Great Lakes and Hudson Bay region, which is not a favorable pattern for severe weather. You've got a ridge trough pattern over from west to east across the U.S. to get big severe weather, you need a trough ridge pattern across the U.S., development of a low-level jet out ahead of that trough. But this is the opposite of the pattern that leads to favorable severe weather. But around May 15th is when those chicklets begin to break down this ridge trough pattern. But here on May 13th, you can see the ridge trough is still dominating. So we're going to have a lot of time to go through case studies. I do want to break down the synoptics a bit more on the relationships between these mid-level troughs, the surface lows. We may have to bring in what's called QG theory, quasi-geostrophic theory. They're basically long equations that show that you get upward motion ahead of the troughs. You get low-level pressure falls in the inflection zone ahead of the troughs. Warm advection, for example, ahead of these systems can lead to vertical motion, the development of precipitation. But this will be good for me, too, to brush up on all these equations. You really just start off with the geostrophic equations and make some assumptions, and then you develop these long equations, and then you break them down and try to interpret what they mean in the atmosphere. But we have supercomputers that break down these equations and pump them out into forecast models. Robert, my windows are pretty fixed. My windshield's fixed. The only windows that I have issues with are the sunroof and the back left window, but I've got flex tape on the sunroof. That's working fine. Back left window is just open, but I'm going to put some flex tape over that also. Megan, I don't know if it's harder to predict a Dixie Alley outbreak than it is in the plains, but it certainly is harder to chase. I believe that Dixie Alley is a lot more complex in terms of Tornado Alley. Because there's a lot less of a capping inversion as well, so storms can happen in the morning, afternoon, evening. Different waves of convection can cause the outbreak to turn out differently than the models are showing. And little subtleties in the development of convection throughout the day can lead to different things. I believe in Dixie Alley, you can either target the surface low track, which sometimes has a lot of QLCS tornadoes, or you can go for renegade storms that can develop anywhere throughout very large warm sectors. So you have to decide whether you're going to start way out in advance of these tornadoes and these storms, or are you going to be aggressive with them and potentially miss the development of the tornadoes. Another thing that makes it more challenging to chase in Dixie Alley are the fast-moving storm motions. So everything evolves so quickly that if you make one error, you can really find yourself out of position. I feel like in the Great Plains and traditional Tornado Alley, things evolve a lot more slowly, and you can see it coming a long ways out with those capping inversions that we showed you on the sounding with that warm air just above the ground. It usually delays convective initiation until the late afternoon and evening, so there's a smaller window to get that convection. And I believe that the convection is more tied to fronts like dry lines, warm fronts, and cold fronts. So you get less the development of renegade cells out in the open warm sector. Usually it's a little bit easier to target triple points and dry lines and warm frontal events. So I think that yes, overall severe weather is a lot easier to forecast in the Great Plains. It's more complex in Dixie Alley, but it's especially a lot more complex to chase the Dixie Alley events. Yeah, Julie, I'm gonna try to do some snake searching out here in Colorado too. Some rock flipping, worm picking, maybe out on Table Mountain. But I've got to get a good pair of boots just so they can't bite my ankles. But I'm definitely a naturalist. Yeah, I wouldn't be too intimidated by the math. You just got to be patient. And it seems like when you have these long math equations and you relate those equations and that math to what's happening in the atmosphere, like a tornado or an occlusion or development of a surface cyclone, then it starts to make a lot more sense. At least for me it did, than just the math by itself. In this video of the Tescott tornado, this tornado is starting to become vertically stacked and occlude. So analogous to a synoptic cyclone, this cyclone is becoming vertically stacked. The tornado has probably reached its peak intensity and then it slowly starts to fill in. The pressure begins to rise, and then the tornado slowly weakens. Sometimes, though, they'll undergo a little bit of an intensification phase as they rope out and get a bit skinnier like that. But really, it's incredible to see the parallels in storm structure and what happens with these storms, the cycling of those tornado vortices, the interaction between vortices on a smaller scale and the overlying mesocyclone is so similar to that in a synoptic scale that it's really incredible to watch play out. That's right, Justin. It's been a slow storm season so far in Oklahoma. We did have the one outbreak there in southeastern Oklahoma, but it's going to come. I think it's going to be that second half of May. And the scary thing is, you remember 2013, overall, that was a very below normal season. But then in 2013, there was just a 2-week period in the second half of May where there were monster tornadoes, including the El Reno tornado, the EF5 that hit Moore, Oklahoma, the May 17 outbreak in central and eastern Oklahoma. You had the Roselle tornado in western Kansas on May 19. Another example of that with overall a pretty below normal season and a couple weeks of very active was in June 2014. You had the Pilger Day, you had the Coleridge intercept, and then you had also in southeastern South Dakota, those tornadoes near Alpena 3 days in a row. That was similar to 2013, where you just had that basically 1 to 2 week period of activeness, except it was later on in the season. And so I imagine that we are going to see an active second half of May. That's pretty obvious with these chicklets here. But these are definitely not guaranteed, including this season. These chicklets before were forecasting a pretty active early May. As you can see, very late April into early May was supposed to be pretty active. It ended up not being that. And this is also a tool to see how forecasts did in hindsight. And that's what you can see here. You can see the development of those blue areas there, averaged across 48 grid points across the CONUS, or continental U.S., after a period of activeness. So you really got to take these just as model guidance. And but it does make sense that after 10 days of ridge, even 2 weeks of a big ridge in the western U.S., that we're going to have a reinvigoration of tornado season in the late May into early June period. So that's really what we've got here today. I'm going to start doing these daily severe weather briefings every single day. I really want to start breaking down some case studies too, some more recent events. Maybe we can break down the recent outbreak there in southeastern Oklahoma when we intercepted that tornado. I still wish I was on the Medill tornado, or maybe one of those down in near Caddo or north of Durant. That was my original storm, but still got to see some decent tornadoes. We weren't able to find the damage path there of the Springer tornado, and Aaron and Trey Greenwood were going to head out there today, but then they found something where residents of the area near Doherty, Big Canyon, and the Dolease rock plant will actually shoot you on site if you go onto that land. So they read that, got cold feet. So we may not be able to survey that. I'm hoping some of the news helicopters in Oklahoma will be able to get in there and find that tornado so they can upgrade it from an EFU. Otherwise, when I get back to the Southern Plains, we'll try to get out there, maybe wearing camouflage or something. We're working on getting permission from Dolease, who is a concrete company out there in central Oklahoma. But we'll see what happens. Thank you guys for joining me today. We'll keep breaking down these chicklets, the long-range CFS. And I'll be chasing these next 3 days. Tomorrow, maybe near Denver or southeastern Colorado. And then on Sunday, definitely southeastern Colorado. Probably near the La Junta to Lamar area. Looks quite active. And then Monday, an outside chance of severe weather across the Southern Plains. We didn't look at that day in detail. We probably should. And in fact, we probably should just look real quickly at more of the models in detail over the next few days. I feel like I kind of overlooked that just a bit. Let's see what the HRRR does here in Colorado. This is on the Pivotal Weather website, pivotalweather.com. Incredible site for visualizing storms. And this is Saturday at 0Z, so 6 p.m. out here. Let's go a little bit before. Go back to about 21Z, 3 p.m. or so here in eastern Colorado. And here you can see the jet streak. Plenty of flow aloft. And really the key to these high plane setups is getting deep easterlies in the lowest couple kilometers. And that's what you've got. So you've got lee cyclogenesis here that is also depicted by the HRRR, similar to the NAM, Saturday afternoon. You've got deep easterlies, even southeasterlies here near Denver. The HRRR is even picking up at the hint of a Denver cyclone with these northerlies here, just to the west of Denver. Cyclonic, convergent, low-level flow here near and just to the north of Denver near the airport. Overall, though, deep easterlies. Let's see what the dew points are on the HRRR. And these are different than Dixie Alley and Tornado Alley setups. And the HRRR is not ideal for looking at high plains moisture because of its affinity for mixing out the low levels. So we're going to have better dew points in this tomorrow. I'll give you the Reed Timmer guarantee on that. We'll have dew points in the mid 40s here across eastern Colorado. The NAM does a much better job at doing high plains moisture. It seems like the HRRR it's a convective allowing model that's more geared toward traditional Tornado Alley and even Dixie Alley thermodynamics. But out here in the high plains, not as much. But one thing it does show is deeper moisture up here in southeastern Wyoming tomorrow. So don't be surprised if all the indicators are showing an eastern Colorado chase and it ends up happening up here in southeastern Wyoming. I've seen it happen a lot of times. And in fact, look at these tornado soundings up there. So I see southeastern Wyoming being a target tomorrow. Deep easterlies across the lowest kilometer or two, flipping over to westerlies aloft, increasing up to 50 knots. Dew points into the low 50s up there. Decent cape all the way up. Look at this cape, that area between the red environmental temperature and the parcel ascent. This is a textbook high plains day, it looks like, across southeastern Wyoming. It's interesting that the HRRR mixes out all the dew points in eastern Colorado and then has the moisture hanging on across southeastern Wyoming. But that is definitely something you cannot ignore. Energy helicity index in the lowest 3 kilometers is better to utilize in the high plains in the lowest kilometer. The reason why is because usually you get easterly winds in the lowest 2, sometimes even up to 3 kilometers before switching to west or southwesterly at 3 kilometers. So the 0 to 1 kilometer indices only show easterlies all the way up, so it really doesn't show the true low-level wind shear and that directional shift that happens above 2 kilometers. Here you can see the pickup near Lusk, Wyoming, up to the north of Cheyenne. So a lot of people will probably be targeting down here as well, southeastern Colorado. I bet that looks a little bit better, closer to 0Z. And you get a little bit more moisture, closer to 6 p.m. down here. But really, we got to keep an eye on that northern target, southeastern Wyoming. Do we target this area? Do we target near the Denver cyclone? Or do we target this plume coming into southeastern Colorado? And that's on Saturday. Then Sunday is not in the envelope yet. But Sunday also looks like more of a southeastern Colorado day. You could also head down to Raton Pass tomorrow. I think that's another target down here. Trinidad to Raton Pass into the western Oklahoma Panhandle. But really, I'm liking that Wyoming target. That's really the only thing that shows up as robust 0 to 3 kilometer shear. I like to track these plumes of 0 to 3 kilometer shear and instability all the way to the terrain. So this would probably be like a wheatland initiation. And here you can see those storms initiating across southeastern Wyoming and into northern Colorado at 21Z. And boy, the HRRR is definitely wanting you to play basically north of Cheyenne into the Nebraska Panhandle, a supercell that tracks like that. Doesn't really have a lot of convection with the mixed out environment in eastern Colorado. The NAM, though, on the other hand, shows more moisture in Colorado and more of a Colorado severe weather event with the development of those storms near the Denver cyclone. A complete void, lack of storms to the north. Let's look at the wrap. Doesn't go out far enough. There we go. So this is the wrap forecast for Saturday evening. And boy, the wrap shows a lot of convection in northeastern Colorado and southeastern Wyoming. It's got a renegade there in western Nebraska. The wrap probably maintains deeper moisture into northeastern Colorado, but still has the development of these supercells in southeastern Wyoming more so. We can drill in a little bit closer. But boy, even the wrap pools that moisture across southeastern Wyoming into far northern Colorado and mixes out a majority of eastern Colorado on Saturday. So based on this model guidance, if everything holds true, I'm going to be driving up to southeastern Wyoming tomorrow. Didn't expect to be in southeastern Wyoming in May already, early May. But I have seen tornadoes in Wyoming in May 2018. We had the May 28 incident where there were horses lofted. Better thermodynamics out here. We'll probably have easterlies through a deeper layer, like is depicted by the HRRR. Deep easterlies. But yeah, southeastern Wyoming into far northern Colorado tomorrow. Basically the same target as today for those high base storms. Today, though, is moving day for me, so I'll be chasing tomorrow, but not today. But certainly keep an eye out on this southeastern Wyoming threat for tomorrow. Deep layer shear, instability, decent moisture, easterlies through the lowest kilometer. This has the classic signs of high plains insanity. So thank you, everybody, for joining me on this. And we'll keep an eye out tomorrow. I'll go live first thing tomorrow morning before the storm chase down there in southeastern Wyoming. And we'll decide whether to target northeastern Colorado or southeastern Wyoming. Thank you, everybody. Never stop chasing.